Okay, first question. What is the total cost of tickets for Mr. and Mrs. Jones and the children? So what I'm going to do first is have a look at just the children. So in terms of the ages, 4 years of age means they go free. 12, 9 and 7 is half price. Half price is going to be half of 15 quid. So half of 15 quid is £7.50. 3 of them, so £7.50 times 3, or you could have added it 3 times, is £22.50. So that's the cost of just the children. And then I'm going to look at the adults. Well, there's Mr. and Mrs. Jones. So if we've got Mr. and Mrs. Jones, it's 2 15 quids, which is 30 quid. So to find out the total cost, it's going to be them two added together, which is £22.50 and £30, £52.50 in total. 6 marks, but 4 marks available for the maths. So a mark available for £7.50, second mark for £22.50, third mark for 30, fourth mark for the final answer. 2 for your layout. Okay, now for this question, even if you had the last one wrong, but you found 10% of your previous answer, you're going to get 2 marks. So how do I find 10%? We'll divide by 10, so that's going to be £5.25. Then take the £5.20 off, it's going to give me an answer of £47.25p. Okay, this question, how far away from home was Gareth for 1,500 hours? Well, there's 14, there's 16, 15's in the middle, so we go up and across. That's nice and easy, 6 kilometres. Okay, for the next one, zoom out a bit so you can see it. At what time did Gareth arrive back home? So, again, here's when he's 0 kilometres away from home. Up, 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 up. Down is where, when I come back here, this is where he's home. So, what is the time here? Well, careful, 1,800 hours, 1,900 hours, in between the two is 1930, 7:30. Sometime after 5 PM, Gareth headed for the supermarket. It was closed, he got there, he headed straight back home. So if we just have a look here, here is where he goes somewhere which is further away from home, but instantly turns around. So this is the point where he's obviously arrived at the supermarket. So what have I got there? Time of 1830. The last one, Gareth did not stop for the whole time between 3 and 3:30. What could the travel graph say? So that is actually by here, this little line. So if he didn't stop, but the distance away from home remains the same, a few different things we could have written. I've written just remained the same distance from home. You could have written he sat in traffic. So he's still in the car, but distance from home hasn't changed. Okay, this one here then. How far did David walk in the first hour? Well, there's 10, there's 12, so the first hour here is 11. So how far did he walk? It's between 4 and 6. So my answer is 5 miles. Nice easy one to start with. Next one. David stopped for a rest. For how many minutes did he stop? Well, this is the rest, because it's horizontal. Like we just said, 10 squares is an hour. So if there's 5 of them, it's 30 minutes or half an hour. Without calculating any speeds, explain how the graph shows that David walked more slowly after his rest. So, you're going to have to talk about the gradient. The steeper the gradient, the quicker you're walking. So the flatter the gradient, the slower you're walking. So let's have a look at what I've written. Gradient of the line isn't as steep. Okay, so that's fine. Next one. We're going to use this information now to finish off our graph. So I'm just going to remove this. At 1 o'clock, David stopped for lunch break for an hour. So if he stops, you know it's going to be across. David then continued his walk at a constant speed. He completed a 12-mile walk up 16:12. Complete the graph. So here is where he stops for an hour. Then 16:12, well, 10 little squares. That means each little square, 1 hour, careful. You'll divide in 1 hour by 10 squares, which is 6 minutes, because there's 60 minutes in an hour. So 412 is going to be 2 squares across. Okay, so it should go straight down to there. Okay, I'm not going to explain this one. I'm hoping it's a bit of common sense. I'm just going to leave it there for you to have a look at. Okay, for this one, Stacey was asked to explain which of the following is better to buy. You need to know the conversion, 3 kilograms or £5. So the conversion you need to know is 1 kilogram is equal to £2.2, but I'm sure somebody will tell you that when you're working through it. So if you now know 1 kilogram is 2.2 pounds, I'm going to change 3 kilograms to pounds, so I'm going to times it by 3. So 3 kilograms must be 6.6 pounds. So which one's better value for money? Well, they're both exactly the same in terms of cost. So what would you rather for 80p? 6.6 pounds or 5 pounds? Obviously 6.6 pounds. So the first one is best value for money. Okay, for this one you can see I've already drawn my line of best fit, but let's just first focus on the question below. Use a diagram to complete the manager's tables. So for number of visitors, there's a gap where it says the entrance fees is 5,300. So that's just looking here, 5,300. So I'll go across to up to 5,300. So that's up here. So 5,100, 200, 300 is not going to work because 6,000 it is. If I look, 5,500 would be here. So 5,300 is going to be 4 squares below. So we're going to be looking by here, which is going to go down to 410. Okay, again, be really careful with your scale. For the next one, where the number of visitors is 425, well, if there's 450, there's 400, 425 is somewhere in the middle. So we go up, that one's here. That's quite nice, so that's going to be at 5,500. Okay, the next question, it says, describe the relationship between the number of visitors to the theme park and the entrance fees. Well, that's quite obvious. The more visitors you get here, the more entrance fees collected. Nice easy mark. Next one, draw a line of best fit on the scatter diagram. Now when you're drawing a line of best fit, you need to evenly split all of them. So you know there are 10 different crosses on here. So you need to make sure there's roughly 5 either side of your line. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So mine splits it perfectly. 1 mark for that. And then the last question, estimate the entrance fees that would be collected on a day when 300 visitors came to this week. So we're going to go using our graph now, go to 300, draw a line up and across, which is what I've done. Okay, you can see it's as accurate as I can get it. And then by here, it's about focus on the scale again, and that should drop at £4,400. You may have something slightly different. You have to draw this line on, and then you'll get the marks. Okay, for this one, if the school bought 17 notice boards, but you get 4 for the price of 3, well, that would be 4, 8, 12, 16 for the price of 3, 6, 9, 12. So you get 16 for the cost of 12, and then you'd have to add on 1 more for the 17. So it's £8 each. So what I'm going to do is £8 times by 13 instead, because that's actually what you're paying for. Well, 8 times 10 is going to be 80. 8 times 3 is 24. Add the two together, £104. Okay, for this one, show when it can be cheaper. Well, it's all about your layout. So all I've done is just split it up either side. I'll put boards all on the left, get a notice on the right. I'll start with 17 because I know 17 cost me 104 from the previous question. Then for get noticed, I'm going to find out the cost. Well, 10 of them are going to be full cost, £8. 7 are going to be half cost, 7 times 4. Add the two together. So 17 boards here is 104. 17 boards here is 108. So then I'm going to go to 18 boards. Well, 18 boards, I'd have to add on another £8 here because you wouldn't get the offer because there's only 4 for the price of 3. For this one, you get another one half price, so I just add on another £4. 112 is exactly the same. I'm going to go to 19 boards. Well, 19 boards is £120. Add on 4 here to get noticed, which is going to be £116. So by here, now get noticed is going to be cheaper. If I went to £20, it'd be 120, and £20 would be 120 again. It's the same cost. And then for 21, it'd be this 128 or 124. Why have I done it the same here for both 19 and 20? Well, remember, it's 4 for the price of 3. So although you can get 19 boards for 116 quid here, you can get 20 for 120. So you could argue that the second it becomes cheaper is actually when it's 21, because you can get 20 for 120, which is £4 more. So I would accept the answer of 21 boards or 19 boards, if that makes sense. Okay, nice easy question. 12 donuts, which one's cheaper, by how much? So again, I'm going to split it down the middle. Doughboy, Benny's. So Doughboy, 3 donuts for £2.80, so 3 times 4 would go to 12, so that'd be £2.80 times 4. Okay, so that's what I've done there. Benny's, 4 for £3.25, so they times that by 3. £3.25 times 3, so £11.20, £9.75, compare the two costs. £11.20 take away £9.75 is £1.45, so Benny's is cheaper by how much? £1.45. Nice, easy question. 5 marks for the maths, 2 for your workings and your layout. Okay. For this one, guys, whenever you want to show best value, you have to make the quantity the same. You've got 300, 400 and 500 ml. The easiest one I found was to make them all 100 ml. You could have made them 1 ml, you could have made them something larger. You would have been there for quite a while. So how am I going to make this small bottle 100 ml? Well, what do I divide 300 by to get to 100? Well, that'd be divided by 3. For 400, divide by 4. And for 500, divide by 5. So I'm going to divide all the costs by those numbers and then see which one's the cheapest. So let's have a look here. 66p divided by 3 is 22 pence for the small. Divide by 4, 23p for medium, and then divide by 5, 25p for the large. So which one was the cheapest per 100 milliliter? 22, 23, 25, or the medium of 23p? So the small, sorry, that's a complete lie. The small at 22p. So small is the best value per 100 mil. Okay, for this question, Galena needs to buy exactly 800. Which is the best option? You must show your working and consider all the options. So there's 2 different options to make 800 here. So the first way is a 500 ml bottle, which is a large one, and a small bottle, 300 ml. Add the 2 costs together. I've done it in pennies, 191p. The other one is 2 mediums, 400 times 2, 92p times 2, 184p. So which one's cheaper, 191p or 184p? Well, the 2 mediums by 7p is cheaper. Okay, all about angle facts here, guys. These are parallel lines, so because this same straight line cuts all these parallel lines, these angles have got to match up. So if this one's 53, diagonally opposite, that's got to be 53. But if this one's 53, corresponding angles means that A is also 53. But if A is 53, this one's 53, this one has to be 53. You could argue this could also be 53. So how are you going to find the others? Well, quite easy. You could do 53 and take it away from 180, because these are all on straight lines. You could add 53 to another 53. Take it away from 360 and halve it. Whichever way you do it, A is 53, but to find B and C, I'm going to just take away from 180. So gives you the answer of 127. So A 53, B and C 127. But then D's a little bit harder. I can see a triangle by here. So if this is 53 and 87, and then D here, what do angles in a triangle add up to? 180. So I add 53 and 87, which is going to take me to 140. So this one here has to be 40 degrees. 53, 127, 127, 40. Okay, this question here. Write down one criticism of it. Do you think it is right to play all of England's international matches down in London, which makes it difficult for people? So I'm going to stop there, Eddie. It's a very leading question. It's telling you it's difficult for people from the north of England to attend. So what is wrong with it? Well, it's a bit biased, all right? It wants you to take yes by reading it. So all you have to write was the question is biased, or it's misleading, or it's leading you to make a certain answer. The next one says, give 2 reasons why the second question is not suitable. So let's have a look at the second question. How often have you visited Wembley Stadium in London? 1 to 5 times. Well, what if you've never visited? So that's one option, is there's no option for 0. And then the other option is, or the other thing which is wrong with it, is times is no time frame. Does that mean monthly, weekly, yearly in your life? Who knows? No idea. So no time frame and no box for 0. Okay, loads of different ways you could do this. Whenever you're fitting something in a rectangle, you need to think area. Now, what I know is that if each square carpet tile is 0.5 meters and it's 8 meters wide, 6 meters down or high, I'm just going to see how many 0.5s I can get going across and how many 0.5s I can get going down, and then multiply the two together to find out how many tiles I need. But you could have done it other ways. So 8 meters divided by 0.5 means I'd need 16 tiles. When you divide by a half, it's the same as doubling. 6 meters divided by 0.5 is 12 tiles, so I know I can fit 12 tiles across. So if I can fit 16 across, 12 down, to find out how many I need in total, well, I times them by 2 together, which is 192 tiles. It's going to get you 3 marks, sorry. 2 marks for these two. And then for the cost, it's 192 times £2.50, which is going to give you an answer of £4.80. There's the workings there for you to see. Alright guys, for this one then, it's just about finding a suitable scale to go up in. As you can see, I messed it up at first. I did go 1, 2, 3, 4, 5, etc. But now I then went up in 2s. Because I need to plot 5 kilograms is 11 pounds. So I go across to 5, get out of the way here, across to 5, up to 11. So that's here, put across. I then use the other one, which is 2 pounds and 0.9 kilograms. So 2 pounds, 0.9 is going to be 1 square below 1, and then join it up. As you can see, it goes from 0. Well, that makes sense, because if you have no weight in terms of kilograms, you can have no weight in terms of pounds. So 3 marks available for that. Make sure it's a perfect straight line. Next question then, it says a person weighs, so I can hear, person weighs 10 stone. 10 stone is 14 pounds. What have I done? I've multiplied 10 by 14 to say that 10 stone is then going to be the same as 140 pounds. So let's go to my graph then, because we need to change it to kilograms. However, what you can see is 40 is not on there. So 140 is not on there, sorry, or 14. So you could kind of estimate it if you went all the way up to the top. What I'm going to do though is go for a number I know I can get to 14 or 140, which is 7. So 8, 6, 7 is in the middle, across and down is 3.2. So again, if you've got something slightly different, we should have something similar to 3.2. I'm then just going to see if I can get that to 140 pounds. So 7 pounds is 3.2 kilograms, 14 pounds is 6.4 kilograms. So what do I times 14 by now to get me up to 140, or 10? So 140 pounds is 64 kilograms. The mark scheme says you can have any answer between 63 and 64. Okay, this question here, write down the nth term. So for the nth term, start by finding what it's going up in. So as you can clearly see, it's going up 4 every time. So it's got to be 4n, and then you always go back 1 step from the number 9, which takes you down to 5, and that's what you add on every time. So the answer is 4n plus 5. 1 mark for each part. So you could have 4n, but not the plus 5 bit, you get a mark for that. Now I'm going to use this, because this is a rule for the sequence. It's just how you can find any number in the sequence. Karis says that 149 is in his diary sequence. Is Karis correct? Well, to find out any number in the sequence, you do 4 times whatever number along it is, and you add 5. So I'm just going to reverse it. I've done it as an equation, but you may have done it slightly differently. What have I started by doing? Well, taking away 5 from 149, which leaves me with 4n equals 144. Then what have I done? I've divided by 4 to see if it goes into it. 144 divided by 4 is 36, using my bus stop. So why have I written yes? It just means that the 36th number long would be 144. So yes, it is in the sequence. Only 1 mark available for that though. Okay, they do love a sequence question with some sort of picture. So my advice straight away is, if you've got pictures, count each pattern and write it down. 6 squares, 12 squares, 20 squares, 30 squares. Okay, I'm going to get a mark just for doing that, and it makes things a lot easier when it's in numbers. Now what you can see is that in this sequence, it's not going up perfect numbers. So it's a bit trickier now. I'll just move this to the top. So 6, 12, 20 and 30 is our sequence. That's after pattern 4. The next question says, can we check 110 is in pattern 8? So what have I done? Well, I've written the first 4 pattern, found out the sequence was going up 6, 8, 10. So it must be going up 12, 14, 16. So it's 2 more every time until the previous number went up. So all I continued to do then was just add on. So 10 add 12 will take me to 42. And then 42 add 14 is 56. And then 56 add 16 is going to give me 72, I believe. And then 18 added 72 is 90. So pattern 8, 110 panes. Let's have a look. 1, 2, 3, 4, 5, 6, 7, 8. No, 8 actually had 90 panes. Okay. The last question we're going to leave. Okay. Really, really, really popular question, this, guys. Always comes up. Cumulative frequency, what's the difference? These are now all in groups. Now they just go from 0, less than 15, less than 20, less than 25. So it means you've always got to include the previous number. So it's simply adding on each one. It's like a domino effect. 0, 3, so 3 goes there because 20 or less is 3. For 25 or less, it's the 3 and the 4, 7. Next one, it's the 3, the 4 and the 8, 15. So just adding on to the previous number every time. The final answer there is 24. Then what you're going to do, you're going to plot it like so. Now, I haven't done this yet. I deliberately waited. Whenever you've plotted it, it's a freehand curve. Again, be careful of your scale. Now, I'm always going to find my median and my interquartile range straight away. So my median is, I need to go to halfway of 24 people. So that's going to be at 12. Well, here's 10. Here's 12.5. So 12 is actually going to be by there. So I'm going to draw a line across and down for my median and write median on there. I'm then going to go to 1/4, which is half of 12, which is 6. So that's 2 squares above 5. I'm going to draw a line across and down. I haven't even read the next question, but I know I'm going to have to use it. That's 1/4. I'm then going to go to 3/4, which is 18 people. So here's 12, 20, 18 is going to be here, 1 square above the middle. Draw a line across and down. Got to do it with a ruler, guys. That's not very good. Okay, and then I'm going to use these at some point for my next question. So if we just zoom out, have a look at the next question. Use your cumulative frequency graph to estimate the median. Why did I get 28? Well, median was at 12 across and down. 28 is by here. So that is where my answer has come from. For the next one, at the end of the week, if I just skim through it, it tells you at the end of the week, the upper quartile, lower quartile is this. It says compare this results with start of the week. Well, you've got the start of the week here. So obviously, if it's talking about quartiles, you've got to find these and use them. Okay, so 1/4, 3/4 is what I found by here. So my lower quarter is 24.5. My upper quarter is 32. 24.5 and 32. You may have something slightly different, but it will be very similar. Then I'm going to take these away and compare that to my other interquartile range. So my interquartile range for my graph is 7.5. You may have something very close to 7.5 or 8. At the end of the week, it was 8. I've used the 2 numbers they've given us. So what does that tell me? It just says it remains pretty similar. Okay, there hasn't been much change in my data. So for this one, it's a little bit misleading, especially because there's 3 marks. But if it's £2 for half, sorry, if it was £2 for all of them, but now what we're saying is half of them are going to be £0 for delivery, and then the rest of them is going to be double. Well, that's £4, double the 2 original pounds. Well, if it's an even split down the middle, the first half are now free, but then the second half are going to be double than what they were before. It's actually just going to balance out. So there's going to be absolutely no difference. So that's what you need to say. Okay, for this question, you would have seen it before. So the range, median, and interquartile range, what you need to find on the next page. Be careful with the range. The range is going to be the lowest and the highest. So it's the gap between these two. on both of them, and then your interquartile range is the gap between these two, 1/4, 3/4, and the median is always the one in the middle. Okay, so let's have a look. 50, 49, 30, 28, 25, 30. Okay, the next question says, give a reason to support her decision. So whenever you're talking about a reason, you've got to look at either the median or the interquartile range. I'm going to focus on the median. Why have I said Nowbury? Well, because the median in Nowbury is 2 millimeters lower, so less rain. Easy as that. Okay, next one, guys. Remember, these have to add up to 1, so 0.6 and 0.4. It already gives you 0.2, so that's got to be 0.8, and then I've duplicated it. Now, I do teach you, find out what goes on the end of each branch, okay? So for this one, it's 0.6 times 0.8, which is 0.48. For this one here, it's 0.6 times 0.2, which is 0.12. For this one here, it's 0.4 times 0.8, which is 0.32. And for the last one, 0.4 times 0.2 is 0.08. Careful. 2 numbers after decimal point in the question, 2 in the answer. Now for the next question, for the next 2 questions, I've already answered these. I've just got to find which one to use. Calculate probability that on a given day, Marina wears a hat but does not wear gloves. Wears a hat, does not wear gloves, 0.12. Written that there. For the next one, so I zoom out, it says calculate the probability on a given day that she does not wear a hat or gloves. Does not, 0.08. Nice and easy. Okay, for this one here, I actually ignored this bit and just gone straight down here. But where's 0.9 come from? It says the probability that she wears a bracelet and, that's in bold, and wears a necklace, 0.7, and wears a necklace. So 0.63 would have gone on the end here. So how did they get there? Well, it's 0.7, the chance of her wearing a bracelet, times by the necklace has got to get you to 0.63, which is why this was 0.9. Okay, and then it's nice and simple, fill it out because it's got to add to 1. So if you want to, you can fill out the rest. 0.7 times 0.1 is 0.07, and then 0.3 times 0.9 is 0.27, and 0.3 times 0.1 is 0.03. Now, find the probability that she does not wear a bracelet. Well, I've probably already answered it. So does not wear a bracelet and does not wear a necklace. Boom, 0.03. Okay, this question here, where have I got the answers 4, 7, and 5? Well, let's use these 2 pieces of information here. 5 students study only biology. Well, only biology has to go here. These mean you study other subjects, so that's nice and easy for the first mark. 13 students study chemistry. Because it says 13 students study chemistry, that means all of the circle must add to 13. So 2, 6, and 1 takes me up to 9. So then to go here, it's got to be, because it's the only gap not filled out for chemistry, it's got to be 4, 2, 6, or 6 and 4 is 10, add the 2 is 12, add the 1 is 13. So that's where that comes from. And then the last one, 7, why is it that? Well, there's 28 students in total, it says that at the top. So I've added up all of these previous answers, then taken away from 28 to find out how many people were left just for physics. 1 mark for each correct number. Next question says, how many students study biology and chemistry but not physics? So biology and chemistry is here, not physics, so you wouldn't include that one. So biology and chemistry would have to be 2. That's where I got the number 2 from. The last one says, one of the students studied at random. What was the probability that this student studies biology? So because it says studies biology, you've got to assume it's in the whole circle. So I'm going to add these up, because any of these study biology. 5 and 2 is 7, add the 3 is 10, add the 6 is 16, so that's 16 students out of how many? 16 out of 28. Last but certainly no means least. Okay, whenever you see relative frequency, it's just a posh way of saying they've done an experiment and they set it up in between certain numbers. And the certain numbers here is every 20 throws, 20, 40, 60, 80, 100. Every 20 throws recorded the chance of getting an even number. So after 20 throws, there was 14 evens. Then after 40, well, I'm going to use this here, 14 and 8 is 22 out of 40. So for the next one, I've added it on again. So similar to what you do in cumulative frequency, 36 and 60, 52 and 80, 62 and 100. Okay, what have I then done? Well, I've made decimals. So times this by 5 to get over 100, and that would give you 0.7. Just divided by 100 then. For this one, you could double it, it'd be 44 over 80, and then add on another 11, because that would be half of 20, which would be 20. For this one here, simplify it, 6 and 60 is the same as 6 over 10. Well, that's nice and easy. For this one here, you could simplify again and then get it over 10 or 20 perhaps, and eventually you'll find out it's 0.65, and the last one, 62 over 100, is nice and easy, 0.62. Okay, so you may need a bit of help with this, but in terms of converting it to decimals, but the first part here is quite nice. The next one says, use the above results to write down the best estimate to give the probability. Well, why would you go for 0.62? Well, the more throws, if you were doing an experiment, the more throws, the best estimate. So why is 0.62 the best? Because you've done 100 throws. Okay? Right, last question. Explain why you think, or explain what you think might happen to the relative frequency if the experiment was continued. Well, again, the more throws there are, eventually it's going to stabilize. You're going to get pretty much the same answer. So I've just written the results will stable, they will smooth out, okay? Or they'll remain the same. You can't say anything like that. Now, last one says, what would be your best estimate of the probability of obtaining an odd number? Well, the chance of an even is 0.62. We just said that that was the best one to go with. So if the chance of even is 0.62, take away from 1, because if it's not even, it's got to be odd. It's got to be 0.38. Okay, if you've noticed, if you've written 0.62, 1 mark, second mark 0.38.